37. Two weights W1 and W2 are suspended from the ends of a light string passing over a smooth fixed pulley. So what is given, children? A pulley is there, okay, and two weights are being suspended. The pulley is pulled up with some acceleration G, tension in the string. You're asked to find. For this, let us try to imagine the picture. So what is given? So here a pulley is there, to which two lights, thing like this, and to the ends of these two light strings, two weights are being attached. So this is weight 1, say W1, and this be some weight 2, that is W2. Okay, so this is what is being given in the numerical. So two weights W1 and W2 are suspended from the ends of a light string passing over a smooth fixed pulley. If the pulley is pulled up, pulley is this thing, children. So pulley is being pulled up. So given that the complete system, whatever is there, so let us assume this complete system. Pulley means the system, whatever is there. So when the pulley is pulled up means the whole W1 weight is pulled up, W2 is pulled up, the strings will go ahead, everything will be going up. So that means the pulley is accelerating upwards with an acceleration of G. So what is given that? It is accelerated upwards with an acceleration G. This is what is given. So I hope you remember the pseudo forces and all. So whenever a body is being moving in one direction, then the pseudo force must be acting in the opposite direction. So whenever the pulley, the complete system, pulley is being acting upwards, there must be, according to Newton's third law of motion, for every action there must be an equal and opposite reaction. So pulley is pulled upward means some pseudo force in addition must be acting in the opposite direction. So because of that pseudo force, let us see what happens. So clearly we know that the weight W2 must be acting downwards and the weight W1 is acting downwards, tension in the string upwards and tension in the string upwards in the second case. This is the general system. But when the complete pulley is pulled upwards, there must be some pseudo force acting in the opposite direction. That means with an acceleration, same amount of acceleration, that is G. So because of that pseudo force, this weight, whatever is there, this weight, so let us suppose that mass of this is some m2 and mass of this is some m1. Then this mass into that acceleration, so m2g must be acting downwards. Here also m1g must be acting downwards. This all happens only because of that pseudo force. So now if you observe the figure, so case 1, m1g downwards, w1 downwards, t upwards. Case 2, w2 downwards, m2g downwards, and tension t upwards. So these things you need to identify. Okay. So earlier the pulley is not accelerated. Earlier examples, whatever we have discussed, pulley is not accelerated in any direction. But in this specified example, the pulley itself is accelerating upwards with acceleration due to gravity G. So whenever this pulley is being accelerated upward, there must be some pseudo force acting on the system that will be pulling that backwards. So as mass is m2, its weight is acting downwards, m2g, and its mass is m1, its weight acting downwards as m1g. Let us assume that w2, mass m2 is greater than m1 or w2b greater than w1. So these are, let us assume that. To write the proper equation, let us assume that this mass is greater than the above mass. But children, we know that W1 is equals to M1G, isn't it? Okay, children. So as we know that W1 is nothing but M1G, or you can also say that M1 is equals to W1 by G. Maybe it is helpful somewhere. So let us keep it aside. Also that W2 is equals to M2G, or whenever you want it, M2 can be written as W2 by G. So let us keep these two things aside. Okay, now let us try to write the equations of motion. So first equation of motion will go, because W2 is greater than W1, let us go for the right side first of all. If you concentrate on the right side, okay, as W2 is greater than W1, this part is accelerating downwards and this part must be accelerating upwards. Maybe the picture is little clumsy, but I need the complete space, children, so try to concentrate here. So let me recall it back. This is W1, this is W2. This is mass M1, this is mass M2. Weight is acting downwards, M1G is also acting downwards. W2 acting downwards, M2G also acting downwards. Okay, tension upwards, tension upwards. Well, as we have assumed that the weight W2 is greater than W1, so this system must be accelerating downwards and this system, lighter weight, must be accelerating upwards. So now let us try to write the equations of free body diagram. So first of all, look at the second part. So for this, if you write the equations of motion, as it is accelerating downwards, so downward forces must be greater than the upward forces. What is downward force, children, here? So this is very clear. Downward forces, two forces are acting. One is W2 and other is M2G. They are acting downwards. So downward force minus upward force minus T must be equals to mass into acceleration. Okay, so what is the total mass, children, here? M2 into acceleration. That's it. So W2 plus M2G minus T equals to M2 into that acceleration. Well, similarly, if you go with the first part of the equation, then as it is accelerated upwards, upward force is greater than the downward force. So if you write the equations for this, upward force is T minus downward force. Two forces are acting downwards. One is W1, the other is M1G. So W1 plus other is M1G. Both are acting downwards, must be equals to mass into acceleration of the first body. If you try solving this, minus T and plus T gets cancelled. So you are left with W2 plus M2G. Okay, this minus, take it inside, minus W1 minus M1G equals to M2A plus M1A. But children, if you observe this, W1 is nothing but M1G, or M1 can be written as W1 by G. So replacing those values, we have W2, keep it as it is, M2G. So instead of M2G, may I write it as W2? Everything I am trying to convert in terms of W's, because options we have in W's, everything masses I am trying to convert in terms of W's. So M2G can be written as W2. This is minus W1. M1G can be written as W1. Okay, so equals to M2. So instead of M2, may I write it as W2 by G? Yes, so W2 by G into A plus M1 is replaced with W1 by G into A. That's it. So W2 plus W2 is 2W2 minus 2W1 is equals to, here A, here A, G, G. So A by G is common both. So W2 plus W1 into A by G. So I have taken out A by G as common. Okay, well, here also if you consider this, I can take out 2 as common. So 2 times of W2 minus W1, bringing this W2 plus W1 the other side, we have W2 plus W1, G to the other side into G is the value of A. The value of A is found as how much, children? 2 times of W2 minus W1 by W2 plus W1 into G. Okay, this is your acceleration. But children, if you observe the question, they are asking us to find the tension in the string. Okay, as we have found the value of acceleration, you can substitute the value of acceleration either of the above equation. Let us go for the equation 1. So substituting the value of A in equation 1, we'll see what happens. Okay, so taking this first equation, children, as it is, what is this? W2 plus M2G. As it is, I am writing minus T equals to M2A. That's it. Well, I need to find out the value of T. So, W2, M2G can be replaced with W2. So, W2 minus T equals to M2 can be replaced with W2 by G into A. So, minus T, bring this to the other side and take this to the left side. Then you are left with W2 plus W2 is 2W2 minus W2A by G is the value of T. This I brought it left side and minus T I carried to the right side. But we know the value of A as this. So substituting there, we have here and here what is common, children? W2 is common. Okay, later we'll take 2W2 minus W2 by G into A. Let us replace this. What is the value of A? 2 times of W2 minus W1 upon W2 plus W1. Difference addition into G. Okay, so if you go through this, you have in denominator G is there, numerator also G is there. So they both will get cancelled. So these two terms are separated by the symbol minus. So here 2W2 is there, here also 2W2 is there. Let us take that 2W2 as common and see what happens. So what is that? Here 2W2 is there. Here also 2W2 is there. So 2W2 both I have taken common. So when 2W2 is taken, removed out, we have 1 minus W2 is removed, 2 is removed. What are you left with? W2 minus W1 upon W2 plus W1. That's it. G is gone. Hence, this is the value of T. This must be the value of T, children. This is the value of T. Take the LCM, children. Then you have 2W2 into this denominator into 1 will be W2 plus W1 minus taken inside minus W2 minus taken inside plus W1 by W2 plus W1 is the value of T. That's it, children. So finally we can conclude. So minus W2 and plus W2 gets cancelled. So what are you left with? This is 2W2 into W1 plus W1 is again 2W1. Denominator we have W2 plus W1 can also be written as W1 plus W2 is the value of T. 2 into 2 is 4. This is W1, W2 upon W1 plus W2 is the value of T. So what is the value of T, children? T is found to be 4 times of W1, W2 upon W1 plus W2. Hence, the correct option must be the first option, that is 4W1 W2 by W1 plus W2. So, look at this carefully, children. Only thing is that extra part it is acting here is M1G and M2G, because the pulley itself is accelerated upwards. There must be pseudo-force that is acting downwards. Because of this, M2G is acting downwards, and here for mass M1, M1G is acting downwards. So, 2 weights downwards, 1 tension upwards, 2 weights downwards, 1 tension upwards. Based on that, you need to write the relation and solve it carefully. But we know that W1 is nothing but M1G, or M1 can be written as W1 by G. Similarly for W2 and M2. So substitute carefully, simplify this, you'll get the result as tension T equals to 4W1 W2 by W1 plus W2. Well, moving to the next question, 38th question. Well, two masses M1 and M2 are attached to the ends of a string. This is your string. So this ends of the string which passes over a pulley attached to the top of an inclined plane. This is your inclined plane and a pulley is attached to the top of it. The angle of inclination of the plane is theta. So what is the angle given, children? Theta. take G as 10 meter per second square and the mass M1 is given as 10 kg, mass M2 is given as 5 kg, angle itself is given as 30 degrees. So, you are asked to find the acceleration of the system. So, normal numerical children, well, if you focus on the concept, clearly we have M2G must be acting downwards and tension in the string must be acting upwards. Okay, for this if you observe, M1G must be acting downwards, and if you drop a perpendicular line to this, if the angle is theta, here also the angle must be theta, because angle drawn between two perpendicular lines always equal. So this is also theta. So this M1G is resolved into two components. Horizontal component given by M1G cos theta. This is given by M1G cos theta, and vertical component given by M1G sin theta. So this is your vertical component and that is your horizontal component, and the tension acting in the string must be some T. So you can have two free body diagrams. So consider the first part of the case. So what is the first part? This one if you consider for M2, let me drop a free body diagram for M2. So this is your M2 whose weight is acting downwards. Okay, and the tension T must be acting upwards. Okay, but we are not aware which direction it is been accelerating. Okay, so before that, let us assume that the body is accelerating downwards. Whenever it is accelerating downwards, the other case must be accelerating upwards. This is only our supposition. Okay, we are imagining that it is accelerating downwards and here it is accelerating upwards, and let us see what happens, the result. So clearly, as I said that this is accelerating downwards, the equation for this can be written as M2G downward force minus T must be equals to M2A. That's it. Okay, well, now coming to the second part of the motion. So what is this? This is in the other pattern. I'll be writing here. So this is your mass M1, upward force is tension T, and downward force is, what is this children? M1G sin theta. Clearly it is accelerating upward direction. So based on that, the equation of motion can be written as, how to write children the equation of motion? This is upward force, this is T minus M1G sin theta must be equals to M1A. If you solve the above equations, what happens? This plus T and minus T gets cancelled. Then you are left with M2G minus M1G sin theta must be equals to M2A plus M1A. That's it. M2G minus M1G sin theta equals to M2A plus M1A. So clearly substituting all the values here, M2 is given as 5 kg, G is given as 10 meter per second square, M1 is given as 10 kg and theta is given as 30 degrees. Substituting all the values, okay, so and solving for A, we have first M2G minus M1G sin theta whole upon, you have A as common, then you are left with M2 plus M1. This is M2 plus M1 is the value of A. Okay, what I considered here is, I considered A, I removed common, then you are left with M2 plus M1. Okay, this M2 plus M1 I carried the other side, then you are left with A. That's it. Okay, so A value is found to be this. Hence the value of A is, what is M2 children? 5 kgs. The value of G is 10 meter per second square. Minus M1 is 10 kg. G is again 10. Sin theta is sin 30 degrees. Sin 30. What is the value of sin 30? 1 by 2. Whole upon M1 plus M2. What is M1? 10. And what is M2? 5. Hence, the value of A is found to be 5 into 10 is 50 minus here again 2 cancel times of 5 times. So, this is again 5 into 10 is how much? 50 whole upon 15. But what is 50 minus 50? 0. So, 0 by anything is 0. Hence, the acceleration of the system after substituting the values is found to be 0. But remember, what is the formula we got for acceleration? This may be helpful for further numericals, children. So, for this numerical, so what we found was the formula for acceleration, we found it as m2g minus m1g sine theta whole upon m2 plus m1 or m1 plus m2. So, this may helpful to you, children, acceleration. So, remember this formula. After substituting the values, we got the value of acceleration as 0. So, I have assumed that this might be accelerating downwards and this might be accelerating upwards. But we found that there is no acceleration of the system. The system remains as it is. Okay. So, neither upwards nor downwards. Okay. Well, so acceleration of the system is 0. But the formula for acceleration of the system is m2g minus m1g sine theta upon m1 plus m2. Well, let us move to the next numerical, that is 39th question. In the above problem, for the same problem, this is the same problem, okay, what is the tension in the string? I know that they will be asking the tension, okay. So, you are asked to find out the tension in the string. Children, so, this was the two equations we have found. So, either you substitute the value of A in first equation or in second equation, you can find the value of tension T. So, let us try to substitute the value of tension T in first equation. So, first of all, let us take this first equation. What is the equation? M2G minus T equals to M2A. What was that, children? M2G minus T equals to M2A. That's it. M2G minus T equals to M2A. Okay. You know the value of A, so you need to find the value of T. Value of T. Okay. So, T can be written as minus T. Let us take the other side. So, M2G as it is, M2A towards left means M2A equals to minus T to the right means plus T. Okay. So, M2G minus M2A is equals to T. Value of M2, how much is the value of M2, children? I hope remember, M2 is 5, M1 is 10. Theta is 30 and G is 10. M2 is 5. M2 is 5, G is 10, M2 is again 5. Acceleration, just now acceleration was 0 is the value of T. Acceleration just now we calculated the acceleration as 0. So, no acceleration. So, 5 into 10 is 50 minus 0 is the value of T. Hence, T is found to be 50 Newton. So, the value of T is found to be 50 Newton. So, option B must be true. Clear? So, either of the equation you can substitute. Okay, I took the first equation, you can try with the second equation. You will get the same result, children. Okay, so answer, the tension in the string is 50 newtons. Well, now moving to the 40th problem. Again, they were saying in the above problem, for the same problem we have to focus on. In the above problem, given that M2 is 2M1 and M2 is moves vertically downwards. So, as the masses are being doubled, the second mass is double of first mass, no doubt it goes vertically downwards. Now, the mass is being increased with some acceleration A. If the position of the masses are reversed, the acceleration of M2 down the inclined plane is. Children, earlier as we have found the value of acceleration as this thing, let us also try to find the value of tension. Okay, so tension from this is nothing but the value of T is nothing but what is that, children? M2G minus M2A, or the value of T, from the same equation, the value of T can also be written as what is the value of T? T is equals to M2 times of common means G minus A. That's it. Well, or after substituting the value of, this is the only exception, children, G minus, what was the value of A? This is M2G minus M1G sine theta. What is that? M2G minus m1g sine theta whole upon, here you have g as common, so take the g as common, then you'll get m2g, here g, took out common, then 1 minus taking inside, minus m2 plus m1 sine theta whole upon m1 plus m2. LCM m2g into, this is m1 plus m2 minus m2 plus m1 sine theta. Already I took the minus inside, no? Yeah, this may help you. Whole upon m1 plus m2. Now if you simplify this, we have plus m2 and minus m2 gets cancelled. Hence the value of t is equals to m1 sine theta. What is common? m1 is common. So we have m1 taken common, m2 already out, into what is left here, 1 and here sine theta, 1 plus sine theta whole upon m1 plus m2 into g is the value of tension T. So that may be helpful for you sometimes, children. T is equals to m1 m2 into 1 plus sine theta by m1 plus m2 into g, whereas A is equals to m2g minus m1g sine theta by m1 plus m2.